Hello everyone, myself Dr. A. Victoria ANAND, Assistant Professor, PG and Research Department of Computer Science, St.Joseph College of Arts and Science, Autonomous Cuddalore. In this presentation, we'll see about stack data structure, which is one of the important topic in fundamentals of data structures. Let's see in detail about this topic. Let's start with the meaning of a stack. Stack is a linear data structure. We are going to store a data into it. It follows a last in first out principle. That is, the element that is placed last in the stack will be taken out first. So it is also termed as LIFO principle. And the insertion and deletion of elements can be done only at the top of the stack. And to represent the top of a stack, we use a pointer called top pointer, which is going to point the top element that is present in a stack. And what is a pointer actually? Pointer is nothing but a variable which is going to hold an address. Here it will store the address of the top location of a stack, and it will change based on the insertion and deletion that is done on a stack. Some of the basic operations of the stacks are push operation, pop operation, is empty, is full, and size. These are some of the predefined operations available in the stack. Push operation represent inserting an element into the stack. And when the stack is full, we won't be able to insert any of the element. And this condition is called overflow condition. Pop operation means we are deleting an element from the stack. And when the stack is empty and we try to delete an element from the stack, then this condition is called underflow condition or underflow state. Is empty will determine whether the stack is empty or not. Is full function is going to determine whether the stack is full or not. And the size function, size operation, will return the number of items or element that is present in the stack. Among this, the push and pop operations are the most important functions or operations. Now we'll see in detail about the push operation. As we know, push means inserting a new element into a stack. And before inserting an element into a stack, we have to check whether the stack is full. If the stack is full and we try to insert an element into a stack, then this condition is called overflow condition. And if we find that space is available and we are in need of inserting a new element into a stack, then the first priority is to incrementing the top pointer by 1. And the new element will be placed at a new position where the top is pointing. And top is actually a pointer which is going to hold the address of the top location of a stack. And this insertion operation can be carried out until we reach a maximum size of the stack. Here also max is a variable which is going to represent us the maximum size or maximum values that the stack is going to hold. The picture representation of the push operation is given here. Initially the top pointer is -1 and it will be incremented each time the element is inserted into the stack. In this diagram it is given the top is initially -1 and when we are going to insert a new element 10 into it, it will be incremented to 0, and next we are going to push 20 into the stack and the top pointer is incremented to 1, and next we are going to insert 30, the top is 2, which is incremented by 1, and this will be carried out until we reach a maximum storage of a stack, until the stack is full. And we are using in the algorithm we are using the max variable, max, which is going to represent the maximum storage of a stack, that is the maximum values that the stack can hold. This is the algorithm for push operation, and actually algorithm is the step-by-step procedure which is going to be followed to complete a work. Here we are going to insert a new element into a stack. As we know that before inserting an element into a stack, we have to check whether the stack is full or not. Here the condition it is being checked, that is, if stack is full, then we are going to return nothing, that is null value, and this condition this block of statement is going to end. And if we are going to have we are going to insert a new element, we are going to increment the top pointer by 1, that is top equal to top plus 1, and the new data, the new element which we are going to insert, will be inserted into the location where top is pointing, that is stack of top. The procedure will end here, that is we'll recall it. First, before insertion, we are going to check whether the stack is full. If it is full, we are going to return null, and the block of statement is going to end here. And if this condition is false, definitely we can understand that there is some space in the stack to insert a new element. And before inserting an element, we have to increment the top pointer by 1, and the data will be inserted into the stack where the top is pointing, and this procedure is going to end here. Another important operation of a stack, as we saw, it is a pop operation. Pop is deleting an element from the stack. And before deleting, we know that we have to check whether the element is present in the stack. If we proceed to delete without checking the availability, then this condition is underflow condition. That is, if the stack is empty and we try to delete an element from the stack, then this condition is called underflow condition. If the stack is not empty, we first access the element which is pointed by the top. That why we are doing is that to store the data in some variables and to avoid data loss. Once the pop operation is performed, the top is decremented by 1, that is top equal to top minus 1. This statement will be carried out after deleting, after pop operations. And this diagram is representing the pop operation. Initially we are having 4 elements in the stack and top is 3. Once we pop the element, as we know, last in first out, last element is 40, which will be popped out first, and next 30. The top element, that is the top variable, top pointer, will be decremented by 1 each time when we are doing a pop operation. And finally it will reach a state that is -1, and this state, this state will represent the empty state of the stack, and we can't do any deletion after this state. If we try to do deletion in the empty state, then this state is called underflow state. This is the algorithm for pop operation. First, the condition is checked, that is whether the stack is empty or not. If it is empty, we can't perform pop operation, and that is, it is given if stack is empty, we are going to return null value, and this block of statement is going to be ended. And if we come out of this block, then we can confirm that there is some element to be deleted from the stack, and we are going to store the top element that is present in the stack into the variable data. This is done to avoid data loss. And next we are going to decrement the top pointer by 1, that is top equal to top minus 1, and we are going to return the data that we have stored already. The procedure will end here. These set of steps will be followed for doing a pop operation in the stack. With this, we have covered the two main operations of the stack, that is push and pop operation with its algorithm. Thank you.